Start building bridges.
This is the viscosity best fit line directions for the viscosity lab. This lab includes 3 tubes filled with fluid. 1 tube is red, 1 tube is blue, 1 tube is green. You are measuring how long it takes the fluid to travel a particular distance. When you are done collecting your data, you're asked to take that data and turn it into a graph. As you remember, it takes 2 pieces of information to make 1 dot. You have time, so how long it took to travel, and then how far it took to travel. So time is how far over, and distance is how far up. So you have the red dot at the first distance is here, the red dot at the second, the red at the third, the red at the fourth. Your lines should look something like this if you're on the right track. Now I've actually used different colors because I didn't want to give away which one was the red and which one was the blue and which one was the green. So I picked purple, orange, and blue. That way you wouldn't know which one was fastest by watching this video. Now, when you do this lab, you're going to have to do something called a best fit line. And I'm aware this is something that you really haven't heard of before. Notice that these lines are not straight. They're not straight because you have a tendency when you turn these tubes that it's very rare that you'll have them perfectly perpendicular. They're usually tilted just a little bit, sometimes to the right, sometimes to the left, and this tilt causes a little bit of friction, and then your bubble doesn't move quite as fast as it should. And that causes you to have not perfect data. This also it happens often enough that we need to do something called a best fit line. A best fit line is when you take a curved line like this one here and you figure out what would a perfect straight line have been for this. Now, in this particular graph, you actually can have all the lines connect to 0, 0. The reason is that 0, 0 is a real thing in this lab. It goes just the moment before you hit the stopwatch is 0 time, and the moment before you flip over the tube is 0 distance. So there is a moment where there is 0, 0 in this lab, and so connecting your lines to 0, 0 actually makes sense in this particular lab. A best fit line is when you take a very straight line, like you would take a ruler, and you would connect it from 0, 0 out to the end. Now the trick is you don't want to connect it just to the end dot. You want to find where's the perfect average of all of these dots. Usually you want 2 dots above and 2 dots below the line. So in this case, my best fit line would be about here. Now here, see, I've got 2 dots above, 1, 2, and 2 dots below, 1, 2. All right, so my line cuts in between there. All right, it's a little bit closer to these two than this two, so maybe it should have been a little bit further to this direction, but it's okay. We're just looking for the general gist. It has to be a straight line. So you would have your colored line would be your actual data, what actually happened in the lab, and over the top of that colored line, I want a black line or a pencil line that is perfectly straight, a ruler line that has at least 2 dots above and 2 dots below. So here's another best fit line. As I'm doing this, see out here I've got 2 dots above and 2 dots below. I'm trying to make them as close as they can be, right about there. So here's one below, and this one's below, and these two are above. And my last one right there. These two are below, these two are above. So that's pretty much what a best fit line is. It's kind of like taking a crooked line and trying to average it and figure out what would the straight line be. And that's so that when you look at it, you can say, okay, this one here and this one here, this one's faster. Now let me talk a little bit about speed. When you have a faster line, usually it's the one that's the steepest, like if these were all hills. The one that's the steepest, the hardest hill to climb, that is typically the fastest moving bubble, as long as you put time on the bottom and distance going up. If you flip-flopped that, you're going to have that won't work anymore. So your fastest line usually means the steepest hill, and then this would be medium, and then this would be slowest. There's your extra lab directions for the viscosity lab. I hope